Then we go a bit more into the details of the SIOS data management system. And this goes back to the origin of SIOS. All these sort of aspects were defined in the preparatory phase of SIOS, which ended actually in 2014, I think. And the intention is to provide access to all data that are relevant for the SIOS community. But there is a particular emphasis on data generated by the SIOS infrastructure, and specifically the SIOS core data. The SIOS core data is a separate presentation in this webinar series, so I will leave out the details here. Just mention that it's long-term commitment for the data, so 5+ years at least. So it's not for like process studies or anything like that, but it's for long-term monitoring information. And there is a specific process along those data. The approach that has been chosen for the SIOS Data Management System is to follow the open and free data sharing. So everything is based on that for the time being. It's a distributed data management system, and this is indicated on the right-hand side of this slide, where you have the map. You see all the current data repositories that are integrated into the SIOS data management system. And yeah, they span quite a lot globally. The green dots are the ones that are actively harvested. Not all of those are harvested, for example, for SIOS core data, because there are specific requirements for the core data, but everybody is harvested for process studies or ad hoc data sets that are relevant for the SIOS community. The orange dots are data repositories where we have work in progress in order to integrate them fully, and this is about agreeing on the standards they use in order to expose their data holdings, but also how those standards are used specifically, and we will come a bit back to that. The other principle is that we're using international standards. We are not inventing anything within SIOS. We rely on things that are already in use in the science community globally. And the last part, which was not part of the thinking originally in the preparatory phase of SIOS, but has come through the operational phase of SIOS, we really need to focus on harmonization of SIOS core data. So that means that for ad hoc data sets, we can bring in anything pretty much into the system. For the SIOS core data, it has to be published in SIOS, also in NetCDF according to the Climate and Forecast Conventions or the Darwin Core Archives. If there are gaps, you raise the issue, and then we go into a discussion on the most suitable form of publishing those data. But that's the sort of general rule in this context. So what we do is integration of existing data repositories into a unified system. You have one entry point, the data access point in the SIOS website, where you can search for information. There is also a machine interface that you can pull into your software if you want to. We'll come back to that. We try to improve the impact of data through improving the reuse potential for data. And this has been a challenge for SIOS over time. For example, how well could we support the year of polar prediction? How well will we in the future be able to support, for example, the next international polar year by pulling together information from multiple sources? So that's the underlying sort of the principle and the ambition that we really are pursuing in the SIOS context. We do also link all the information we have in the SIOS Data Catalogue to larger scale frameworks. For example, the SION Data Portal. Everything that is in the SIOS Catalogue gets directly ingested into the SION Data Portal. Another principle that is quite important is that each of the data repositories that contribute to the SIOS data management system have their own existing procedures for data submission, curation, and long-term preservation. So that's not a responsibility taken on centrally in SIOS. It's delegated to the contributing data repositories. There are There is guidance and requirements centrally, but the implementation is at the individual data repository side. So SIOS is not changing existing procedures, but we are bridging between the data repositories using internationally accepted interoperability standards and technologies. And we have developed guidance documentation on how to interpret and use those standards and technologies. Another aspect that I didn't mention earlier is the aspect of, also quite often scientists say that, why don't you just take our data and dump it out so that it's published? As I mentioned earlier, we do think about linking the data consumer with the data provider. So we have to think about the consumption of the data, and not only the perspective of the data provider. And the thinking within the SIOS Data Management System is that we follow this provide once for multiple use. And then it's a bit it doesn't matter whether it's a researcher, it's a member of the industry community, or a management level in a municipality, or a directorate, or a ministry that really wants the data. We try to build services. So the ambitions we have is to address the following functionality. We do offer the data discovery across all the sources of information. So this is the thing that when you search for the information, then we do offer the ability to retrieve the data. And in the simplest form, that is basically a link to a landing page offered by the data repository that is offering the data. Then every consumer has to go from the individual discovery metadata into the landing page of that data set in order to download the data. But if data has a richness where there's actually direct download links or services on top of the data, we can integrate those into services in the central SIOS data management system. For example, we do have a shopping basket. So if there are direct download, you can add the data to a shopping basket, and you can download information from multiple sources in one go from the data management system. We can't do that unless there are direct links to the individual datasets. We do offer visualization of data if it's formatted accordingly. We can't visualize anything. It has to be fair, fully fair compliant, and it has to follow the standards that we've defined in the system, and it has to be served over the interfaces that we actually support. When those aspects are supported, then we can do a centralized visualization of the data, whether it's located in Oslo or in Warsaw or in Tokyo or somewhere else. We do also offer some transformations of the data. You can subset the data, you can reformat the data, you can combine new data sets. The last part is not fully working for the time being, and the reason for that is that we don't have enough information in the proper form to actually develop those services. But reformatting, reprojecting, subsetting, etc., that's actually supported. The aspects of functionality, the main document for this is the guidance for data centers contributing to SDMS. This is not guidance necessarily in general for the individual scientist, although there is information in there that could be relevant for an individual scientist. These documents are available through the SIOS website. At the discovery level, we have a generic model, and there's in the model, in the document that I mentioned now, you can find on the page 10 and 11 a generic data model. So we want to have a metadata identifier, a last metadata update, a title abstract, temporal extent, geographical extent, etc. There's a number of information that we rely on here. But we do also need some of those elements to be formatted in a special way. So if everybody creates their own sort of thinking or way of documenting data, it's impossible for us to navigate and pull the information together. So that's why we work with controlled vocabularies, or what is called semantic technology today, in order both to fully document in a consistent manner, but also to move between knowledge domains. For example, the biological community has a different way of documenting data than the physical community. And one very good example of that is, for example, in the ocean domain, where you have marine biologists that do also collect physical oceanography information, but they use a different kind of terminology and different way of documenting the data than a physical oceanographer. At the data level, SIOS promotes fair data publication and use the CF, NetCDF, and Darwin core archives. Those are absolute requirements for the SIOS core data, and it's recommended approaches for all other data. In SIOS and the website, you will find a number of services, and one important thing for a data provider here is to look at the, let's see if I can find the learnings from the Nansen Legacy project. There were a number of tools developed in that project. The whole service was serviced through the SIOS website. But the most important thing here is the Nansen Legacy template generator. When I said that we do promote, for example, CF, NetCDF, or Darwin core archives, it doesn't mean that we don't acknowledge that people will use spreadsheets for data collection and data analysis. We'll come a bit back to the data analysis part, but we do have, thanks to Luke and Olaf at the Norwegian Polar Institute, we do have a template generator where you can create a spreadsheet that follow the Darwin core, also use the Darwin core or the CF terminology. Those spreadsheets, we know for sure it's easy to convert into a CF NetCDF in order to support the ambition of also define once and serve multiple domains. The illustration with the inverted triangle that I showed earlier. But it's a webinar in itself to go through this template generator. If you have questions about that, ask for a webinar or ask Luke for guidance. Then we are at the website, and this is how it works as it is today. You have a search interface where you have 3 columns. The appearance of this will change during the year. We've got some feedback over the years from different people, so we are developing a fully new interface, human interface to the catalog, which will be deployed probably after summer or in the autumn sometime. We need to redo many of the backend services in order to support the new interface. I will go a bit more into detail on how to use it. This is the advanced user interface, where you have a number of what we call grouping of facets, where we've actually basically analyzed the information in the catalog, and we say that there are for example, 2,723 datasets in the catalog that is tagged with oceans in the isotopic category element. Similar, you have the projects listed up here, and collection is an internal thing that we use at the central location in order to set up subsets of the information. One thing that you will see after a while here is that some of the data sets will be specifically tagged. You can find the Nansen Legacy project data in there, also the NISMOC data in there after a while. Then it's personnel, organization, etc. Everything in these elements, that's actually taken directly from the discovery metadata that people have provided. If there are typos and things like that, it comes from the original data. So that's one of the reasons why it's so important to use controlled vocabularies, so we avoid typos, etc. in the data. In addition to the fully the advanced user interface, you also have a simple search where you can search by keywords. Also, this is a full text search in the terminology used by other providers. You have a date time constraint that you can add, and you can also add a bounding box in the map here, and then you use that efficiently to filter out information that is relevant for you. I will show now a bit on the setup for the search interface, and I use the advanced user interface for this purpose. You have 3 columns. You have a first column where you have search criteria, a second column where you have main results, and then a third column where you have facet criteria, so the grouping of elements. This is a bit complicated since there are some additional facets down here in the first column as well. But basically, the first column is for the full text search, the temporal search. You have pagination options in that page, meaning whether how many results you want to have in one page before you have to switch to the next page to list your results. You have search and reset buttons. In the main results pane, you have potential guidance at the top. You will see some accordion menus which you can expand, and you can get guidance on how to use the system. You see the search results in a map, and then you have the results tabulation. The main issue here today is that the search results map also gives the spatial filtering option for the system. So in the next version of the portal, everything related to search will be in the first column. And then you have the facet criteria here, and we list for the time being project, collection, personnel, organization, and data repository. One thing to mention here is that not all data repositories expose their own identity in the discovery metadata that they expose, and then it's not showing up here. So that's would be a requirement in order to show up there. Yeah, this is just a side-by-side, so it's a bit easier to see. You see the search criteria, it's up here. This is a pull-down menu. So whenever you put in here, for example, USISAF space C space ICE, the system will only show data sets that contains all of these words. I haven't done anything on time or space here. If I search for USISAF Sea Ice here, you will get up 2 versions of the EUMETSAT Ocean and Sea Ice Satellite Application Facility Daily Sea Ice Concentration Analysis. And basically you have one version in a polar stratigraphic map and another one in a Lambert projection. And as you know, the choice of projection actually affects how your data could be interpreted, whether it's an angular through or it's an area through map projection. Yeah, if you use the mouse in the map, you can actually, in addition to go through the data sets in the menu underneath, you can actually go directly to the data set in the menu here. Just pick one of those in there. But if you scroll a bit down, you see that for each of the data sets, you have the ability to add to basket, show extended metadata, visualize. If it has an opened app, the opened app link will be shown directly. And the reason for this is that we use opened app heavily in the distributed manner here, because we then connect to the data set, for example, for visualization services, instead of pulling or downloading the data. You can also export the metadata if you need to, and use that in other contexts. And there are multiple formats available for the export facility here. If you move on and push visualize in this context, and web map service client is launched within the data portal. And in here you can navigate in time. So this is an aggregated product on the ocean's USISAF data. And you can actually navigate using the time slider at the bottom from the beginning of the dataset to the end of the dataset. The similar functionality is available if there is numerical models available in the system. If the models are presented in an appropriate manner in the web map service client, you can actually navigate through the full ocean column or the atmosphere column of the data using, there is an additional button at the bottom here where you have vertical coordinates. So you can go through the vertical levels of a model, for example, down to this bottom of the surface. So there are some ocean models in there that are supported in this context. Up here, you can switch between map projections. Of course, UPS South doesn't make sense here. It's basically for data in Antarctica. And then this is the Mercator, or the standard latitude-longitude grid. And this is a polar stratigraphic projection. What we haven't really supported until now in most of the metadata is bounding boxes that are polygons, also not square, also rectangular bounding boxes. And that's something that it will look a bit awkward when you work on it in the system, but we are working on improving that functionality. So this is embedded in the service of the SIOS Data Management System. If you go in and push the expand metadata, you see that there are data access links for this data set. You have the opened app and you have the WMS. If you copy the WMS directly, you can pull that directly into QGIS, for example, and then you can embed this product directly into QGIS and continue to work with it in that system. Or you can pull it into your Python project or into your R project as well. Looking at a different type of data, I now just switched the search tag up here. So now I look for Verlegenhuken, a geographical location in Svalbard, at the northernmost tip, more or less, air and temperature. So 3 words. All of those have to be available in the data set. And then I get 2 data sets up here. One is obviously a point measurement, so it's a station. The other one is actually belonging to a larger data set which has multiple locations in it. So that's indicated by the point or the bounding box illustration in the map. And again, if I push visualize in here, you can get up the full temporal evolution of the time series. You can navigate, you can navigate through the variables that belong to the data set. You can also do a resampling of the data set. So the original data set will always be shown in the native frequency. But if you want, you can go, for example, for minute data, you can go to hourly, you can go to calendar day, weekly, month end, quarter end, or yearly data. And that is actually done on the fly by the software. So you can have a smoothing of the data. At any time, you can download the visual impression of the data, but you can also select export, the button up here, and then you can select the variables that you would like to pull out of the data set. You can select the time range, whether you wanted the full data set or not, the file format, and I will come a bit back to that, and then you have to decide whether you use the raw data, so the original resolution of the data, or you have a resampled version of the data set that is downloaded. Just pull download and you will get a link in the same view, which you push and you pull out the pull out the data set. If you don't want to use the original netcdf file, or you don't want to download the data as a netcdf file, you just change the export format, for example, to CSV, if you want to have data that you can pull into your spreadsheets. There is also currently a support for Parquet for those that are into machine learning and things like that. Sorry. And we can actually add more types of formats here if you have wishes for formats. again, going back up to the full text search, we did originally write here 3 words, verlegen, huken, air, and temperature, and all of those 3 words should be present in the data set to be shown. You can have also here change this to any of these 3 words. But more important, and this is a functionality that is less evident for people, you say that you want to have these 3 words present in the data. And you saw that I found 2 data sets the last time. But if I now put a minus before air, then I say that verlegen, huken, and temperature should be present, but air should not be present in there. And what's the reason for that? Because in that sense, I've excluded the 2 previous data sets that I just got listed. And the only thing I get listed now is a permafrost station at verlegen, huken. So it's kind of powerful if you know how to use the logical structure in the full text search. And with the permafrost structure, you can do the same thing on the visualization. You can have the temperature down here. You can navigate back and forth in time on the full time series. You can actually change the appearance. So instead of having the temperature profile for a certain time, you can have the time evolution on a certain depth level. And you can navigate that and use that. You can do the same things with exporting as I did show earlier. There is one thing that is supported, but I wouldn't recommend to use it as it is now. It's on our list that it should be improved. There's a quad mesh where you get a 2-dimensional plot of the data with colorized changes in depth and time. That is not scaling well. It's way too slow in the service as it is today, so we need to speed up the performance there. Then we move on to the machine interfaces of the catalog, and I'm now nearing the end of the presentation. Most scientists don't care about this, but it's actually quite powerful and it's useful. I did show you earlier the ability to copy-paste a WMS link directly from the expanded metadata into QGIS, for example. But actually, in the machine interface we are supporting today, we do support the OGC catalog services for the web. The address is here, the OAI PMH, the address is here, and OpenSearch. The first and the third one here, you can directly pull into QGIS. You can directly pull it into Python. You can directly pull it into R if you want to, and make your querying of the catalog directly in your software. So one way of doing it is, for example, here I just show the example with the QGIS. You put a name on it, you add the URL, you identify the type of interface that you have. And when you do that, you can actually search exactly like I did earlier. USISOF, CIS, ICE, I get the same data sets up as I do get in the catalog. I can actually open the information that is retrieved by QGIS, look into it. I see that there's OpenDAP support here and there is WMS support. Both should be supported by GIS software as it is today. I'm not a GIS expert in here. I prefer other mechanisms, but it should be as possible, as I showed, to pull it directly into QGIS and show it. And then you add the data directly, for example, using the WMS part down here. And when you do that, you get it directly in here, and you can pick the layer that you want to pull from the WMS into the QGIS application. This is more for the data repositories. I will skip quite fast through it. It's just we do support a number of discovery metadata exchange protocols. We are constantly working on improving it. More important is that the documentation standards that we support are also constantly evolving. We currently support various flavors of GCMD diff, various flavors of ISO 19115. We do support DCAT, schema.org, and we can also traverse threads catalogs, and extracting ACDD elements directly from the data files if you want to have that. This is actually the mechanism we use in order to integrate data from eagerPass in the current system. When it comes to the discovery metadata harvesting, the important thing here is that if it is garbage in at the start here, the result we get out at the other end, the consumer end here, will be garbage as well. We can't actually fix issues that are present in the input information. But we do have an information flow here where we do translations, etc. The important thing is that we do an incremental harvesting of information from all repositories every night. Then we wipe everything every month, the first of every month, and then we do a full ingestion. And the reason for this is to avoid having stale data sets in the system. We transform the information we get into our own internal model, data model, and there we do filtering information, and we do also some enrichment on the information we get. We can't really fix wrong information, but when there is sufficient information, we can actually enrich quite a lot in the information. I did mention originally vocabulary, standardized vocabularies. We do use the Maps Norway vocabulary service. And the SIOS Data Management System is primarily built around two vocabularies here. We have the climate and forecast standard names vocabulary and the GCMD earth science keywords vocabulary. This is one of the enrichments we can do. If you have, for example, GCMD information within the information that you provide to your data repository, or you have CF standard names in there, we can map it to other things. For example, here we have the CF standard name air pressure, and then we've already linked in the backend services here in the vocabulary servers that to GCMD and also to the CDataNet vocabularies. So this way, using the semantic technologies, we can actually enrich, we can correct errors in the data, etc. So that's part of the things that we do. But the best thing is to make it correct from the beginning. Use the controlled vocabularies whenever you document your data. I did also mention that we are present in the polar context. So this is just the location. Down here, you have the SIOS Data Management System as a node in the polar data ecosystem, and all the data centers we are connected to. This is a graph that is served by the Mapping the Polar Data Ecosystem. It's a joint SCADM and SEAN IASC Arctic Data Committee effort to build this service. So we are well positioned in that landscape. And then the final slide here. It's, as I started with, data management is a collaboration. It's not something that is done by data repositories. It's not something that is done by the data provider. And it's not something where the data consumer is a passive passenger on the journey. It's a collaboration between the data provider, the data consumer, and the data repository in order to build a proper service to serve the data. And that's the intention of the SIOS Data Management System, to have everybody engaged. It's not only the data management group, but it's also the science community of SIOS that needs to be engaged. And sometimes you need to take a step back and raise the perspective to understand the full context of what is what the ambition for the system is. If we can do that, I'm sure we can have a good working system in the future and be well positioned for the upcoming International Polar Year as well. Thank you.